insights and case studies with Pedro Pires with Keysight Technologies. We'll be starting in about 2 minutes. Thank you.
Test, 1, 2, 3. Yeah? All right. So welcome, everyone. Thank you for joining me in this session on modern data management. I'm Pedro Pires. I'm going to share some insight with you. I'm from Keysight. So we are covering a couple of topics today. I'm going to start by talking a little bit about why data is the bottleneck of modern engineering projects. Then I'll go over how our solution, Keysight SOS, addresses those challenges. I'll talk a little bit about some case studies, some practical examples on how we address these problems. And I'm going to wrap up with best practices, gotchas, and alongside some closing remarks, a call to action. So why is data the real bottleneck? Right? There are some trends that we are observing in the industry. So projects are growing in complexity. So we're talking about projects getting bigger in terms of the number of files, in terms of the size of the files, the technologies that are folded into the mix, the methodologies that come into play that have to be coordinated with one another. So it creates this problem of how to collaborate at scale, not only in terms of different teams that are located in different geographical locations, but also how you are going to standardize and bring all these different methodologies together. And of course, when we're talking about collaboration, we're talking about opening avenues for your data to be shared. So this all needs to be done, maintaining traceability of your data. You need to know where your data is being utilized, by whom, and you need to abide by whatever standards and compliance you have in place. So just to scare you a little bit on how this is important, Keysight has done a survey, and we found out that up to 63% of productivity is lost just by having data that is manually isolated and shared and located in silos. So 30 to 40% of the time is spent looking for information, which often leads to not finding the right information or finding incorrect information, and then 20% on top is lost on fixing the data that you found because you found the wrong data. Just by doing some back-of-the-envelope calculation, if you consider a median team of 10 engineers and a fully burdened cost of $285K, we're talking about around $1.8 million that are wasted per year just on manual labor, on managing your data from side to side. Also, tool chains are growing in complexity. We see that over 2/3 of the engineers have to use more than 6 software in the tool chain. And along with this, you have more manual labor, you have more data correlation between different formats, and you have, generally speaking, more data being shared in ways that are not ideal, not standard. Along with this, and along with the growing tool chains, because the data that is being handed over between different tools is done in an ad hoc way, manual, scriptware, customized ways to share your data, you're creating opportunities and instances where your data isn't safe. So every time that you extract the data from a tool and hand it over to the other, that data is not as easily protected as if it were seamlessly changed over from one tool to the other. And the more tools you have, the more the problem grows. In fact, 74% of the people that we surveyed state that spreadsheets are the #1 format for used for knowledge and data transfer. And 72% regularly use paper notes and email to share data. So it's of no surprise that more than 50% of executives in the industry see security as a top concern. And just so you know, 1 out of every 4 global cyber attacks happens to manufacturing companies, and we're talking about around 5 million of average cost per data breach. Now, going back to those instances in which you have to massage the data manually and do it in a customized way, 80% of your engineers have to do this, have to resort to custom workarounds to move the data along the workflow. And if we think just at the border between design and test, 1 in every 2 engineers finds that correlating design and test data the biggest challenge. So these engineers are wasting, or 71% of these engineers are wasting more than 1 month correlating design and test data. So this is why your flows are breaking up, right? There's vast amounts of data that are being produced. They're being produced and consumed by many different tools. This creates knowledge silos and the manual workflows and non-ideal workflows for you to work with. This is fundamentally a data lifecycle issue, and data management is a critical function that you have in your engineering workflow. So what does a modern data management infrastructure look like? First of all, you need to provide the immediate functions, right? The team collaboration capabilities. These are the obvious features that you would expect from a data management infrastructure. The ability to storage, to version your data in a collaborative environment, to share your data across different geographical locations. This team collaboration needs to be there. But as complexity scales and we start talking at the organizational level, you need to provide organizational collaboration. So you need to be able to provide frictionless access to all your data. So everyone in the company needs to be aware of the knowledge that is available in the company. And when we're talking about sharing the data, we're talking again about opening avenues for your data to flow, which creates this requirement for security, right? So you need to have standards on how to do this. You need to abide by whatever regulatory environment you have in place. You need to obviously maintain traceability. You need to know where your data is being utilized and by whom. You need to maintain this organizational memory. This is where SOS comes into play. So SOS is our design data management platform. And the way it is unique is that it provides centralized data and IP management, and IP lifecycle management. So all the way from the management of individual files to the higher level of abstractions like IPs or entire systems. It promotes reuse-driven data management in that every asset that you manage in SOS can potentially be reused by other projects. And when you do so, you do it in a way that you do not lose track of the source of your data. We boast the richest portfolio of EDA integrations in the industry. So it means that you do not have to get out of the tool that you're using on your day-to-day. You can manage your data directly from the cockpit that you're already working with. And beyond EDA tools, we also have interconnectivity with a multitude of third-party tools. Here we are talking about issue trackers, requirement management, build systems. So you can basically construct an entire CI/CD pipeline with SOS at the core. Beyond this, we have a number of optimization capabilities. So we are talking about eliminating all data duplication, sharing the data across geographies efficiently, creating user workspaces that are lightweight, and we have a very simple use model. By the way, I'm being deliberately high level with these descriptions, so as to, first of all, in the interest of time, but also to invite you to our booth where I'd be happy to elaborate on these details with more depth. But just to wrap it up, Keysight is not just a data management tool, it's an organizational memory engine. So now let's have a look at a few examples in which SOS was deployed and solved real problems and what was the effect after deploying SOS. Let's first look at case 1, where we are talking about a deployment for a big analog mixed signal design team. So we are talking about a team of 150 to 200 engineers. 50 to 100 were non-engineers, so we're talking about product managers, etc. And they were distributed across 6 design centers. This deployment, this company was working on 50 to 60 projects per year. Each project would last 1 to 2 years, and we're talking about big analog, small digital. And in terms of their IP distribution, it was focused on analog IP. They were also dealing with third-party procured IP, so they were working with 3 IP vendors, and they were also managing about 50 PDKs and variants of PDKs across their projects. So their challenges revolved a lot around the methodology via which they would reuse IP that was available in the company. So on average, they were copying 6 IPs manually into the projects. A lot of information was being shared and stored in emails and spreadsheets. So on average, they would estimate that if they would have to rebuild the environment of a legacy product, this would take about a week. And per project, they would estimate that they would have around 100 email threads for any number of topics around that project. So their main goals was, 1, to promote IP reuse of internally developed IPs. Secondly, to make IP knowledge available to everyone, so not only have a way to share the IP, but also make sure that everyone knows what IP is available in the company. And third, normalize IP development practices across the enterprise. So the implementation went like this, right? So they were already using SOS, but they already had a lot of IP also in systems outside SOS. Namely, their PDKs were stored in network shared storage devices. Some of their IP was also stored in SOS. So all of that data remained in whatever data infrastructure they were already using. But we published all that data into an IP catalog, such that everyone was aware of the IP that was available in the company. So this IP catalog organized and sorted all the IP that they had in the company. Every IP or each IP within this catalog had a dedicated web page that collected all the information for that IP, all the documentation associated with it, the main attributes. So basically, we gave them access to a search engine where they could go in and look for the IP that was available across the company. So their entire IP reuse flow was streamlined. They were now suddenly able to easily find IP in a single platform. They were able to compare IP directly within the tool. They had approval workflows that were automatically granting or denying access to people according to their level of access. The entire process of integrating that IP into new projects was also streamlined, and then it came full circle, right? If a finished project was also potentially something useful to be used as a component in larger projects, that component was also published back into the catalog as a new IP. Then, over a few months, we measured the improvements in performance, and the key return on investment was that there was a jump of 35 to 50% in IP reuse. The construction of a bill of materials was now 5 to 7 times faster, and they were seeing 80% fewer emails discussion because they had a better way to communicate. And as a bonus value add, their IP producers now had visibility on where their IP was being utilized. Now, changing things a little bit into a different case, which is now a large digital design projects house. So we are now talking about a team of about 100 engineers, 25 to 30 non-engineers. I have no information about how many design centers they had. They were working on more than 50 projects per year. Each project would last 3 to 6 months, and this was a small analog, big digital type of deployments. So naturally, their focus was on digital IP. They were dealing with about 10 IP vendors, so they were also managing third-party procured IP. And I have no information about their PDKs. And their challenges revolved around traceability, right? So first of all, they had a lot of problems in the last mile, the checks prior to release. They were running a lot of validation at the end, and they were taking about 4 to 7 business days to release their projects. On average, 40 tickets were filed per project, which was causing 3 to 4 weeks delay. And the preparation for external audits was taking on average 4 weeks for IP. So there was a lot of time that was being wasted. So their main goals was to reduce IP assembly time, to reduce engineering changing orders because of late discovered IP. So they wanted to proactively react to issues and have a way to know in advance if something was going on. And they also wanted to have a dashboard for traceability and compliance reporting. So just like before, we published all their IP into a curated catalog. We went through the entire effort of defining which IPs they needed. We connected that catalog to Jira. And we then leaned heavily on automation. So all those validations that the users were doing manually, they were now being automatically triggered. Lots of notifications and reporting that was automated so that they could react faster to these issues that were coming about. This was about 6 months of digital transformation in which we measured the improvements in performance. And the key return on investment was that there was a 20 to 25% reduction of the timeline. So they were faster to market. The release process, which was taking 4 to 7 days, now was taking 1 day. The ticket volume was much smaller as well. So from 40, we reduced it to about 25. And the delays that were caused by last-minute issues were reduced from 1 to 3 weeks rather than 3 to 4. And that the audit preparations were also much faster now. And as a bonus aspect, teams were much more productive. CAD could support more projects, managers could plan better, and engineers could document more. Finally, last case, and just to change things a little bit as well, so I'll give you an example of data lifecycle management for AI/ML, because in case you haven't noticed, it's the talk of the town. So in this case, we are talking about a small team, so 10 engineers, 1 manager across 3 design centers. So one was a data center, the other was a development area, and then there was a production area. They were working on 1 to 2 projects per year, which lasted 6 months to 1 year, and their main focus was retrieval augmented generation. It was the AI application that they were working on. In terms of their data, so it was multimodal. We're talking about different types of data. Their data sets were 10K to 20K samples big, and we're talking about 20 to 30 data sets that we were using. Their initial pipeline looked a lot like this, right? So let me see if I can explain this without laser, right? So they had all their raw data in their data stores. They were using scrapers and parsers to create a data set, which was then being pushed into a MinIO service. And then when they finally wanted to work on the data, they would download the data from the MinIO service. They would extract the embeddings of that data. That the vector formatted data would then be transferred over the network to their production area, pushed into a PostgreSQL database with vector plugins so that the RAG service could do vector operations on them. And the modeling just the same, right? They would create the model in the development area. They would transfer it over with SCP into the production area, deploy it into the RAG service. And all of these processes were basically very manual. So their main challenges was that they did not have any formal data set and model versioning nor lineage tracking. So they didn't have a seamless way to say, OK, this model was created out of that version of the data set. So they needed this traceability. They also didn't have quick and easy ways to understand what changed across different versions of the data set. And basically, their entire ETL process was highly manual. So their main goals was to streamline their ETL pipeline, enable easy comparison, easy diffing of different versions of the data set, and enable data set and model versioning so that they have an end-to-end digital thread across the entire pipeline. So this is what we did. So this is their original pipeline. We, of course, started by replacing the MinIO data service by an SOS database. Now, a couple of notes about that. Their data sets were basically being stored as different directories, whereas groups of these directories were actually different iterations of the same data set. So what we did is that we stacked all those data sets as different versions of the same object, which is more or less trivially done, but then it would enable interesting features, right? So now suddenly they have configuration management capabilities. They have the way to quickly and easily select different versions of the data set. Different users could use different versions of the data set to work on their modeling, and they, on demand and in place, could change the version of the data set that they were using. They could also tap into more advanced features into this, right? So now suddenly they were able to do stuff like, for example, compare different versions of the data set. They were able to easily diff versions and understand which files changed, which files were removed, which files were added. Now back to the pipeline. After replacing the data service, we also automated the entire ingestion system. So now there was an automation that would basically be triggered by the user, would consume the data and push the data into SOS. The entire vectorization pipeline was also automated. So now, instead of the user having to do it manually, every time that we push a new version of the data set into the database, it would automatically trigger an embeddings extraction. The embeddings were created, ingested back into SOS, and we would establish a relationship between the raw data set and the embeddings. And then the modeling was the same, right? So we had a development work area where they were working on the model. The model was also being ingested back and versioned by SOS. And finally, on the production area, there was a work area connected to SOS that was automatically updating every time that there is a new iteration of the objects, of the artifacts. And this work area was also automatically pushing the vector database into the PostgreSQL database and deploying the model automatically into the RAG service. So essentially, what the user was doing is just triggering an ingestion of a new version of the dataset, and the entire pipeline downstream was happening automatically. And because we were using end-to-end lifecycle management, so all these artifacts that were involved in the pipeline were being consumed and versioned in SOS, it was very easy to reproduce previous experiments, right? Because now it's very easy to know that if for model 6 that was created with embeddings with a specific revision, you use the specific revision of the vectorization logic. So it was very easy to backtrack and redo previous experiments. So the key return on investment was that the life cycle of the pipeline was reduced by 98%. Now they had built-in tracking and diffing, eliminating all the data preparation steps and the manual labor across the pipeline. The human intervention was just needed at the beginning to trigger a new refresh of the entire pipeline. And they had complete visibility over data to model lineage. I'd like to go over a few best practices and gotchas just to wrap up the presentation, right? So this is, imagine that you decide to now deploy SOS because SOS solves all your problems. There are a few best practices that I can share with you. First of all, you should consider the SOS architecture, right? It's a very simple architecture. It has only a few pieces. You have the work area, you have the cache, you have the primary repository, and optionally you have the backups as well. So each one of these components has different needs. So you should deploy them in a tiered approach, right? Something like this, in which for caches and work areas, you have them deployed in machines that prioritize I/O performance. For the primary, you need I/O performance, but you also need storage. So you should put them in a place that has space to grow. And for the backups, you don't need that much performance. You can deploy it in a place that has ample space to grow, but also is reliable. There are a couple of recommendations here that I'll leave just for reference. I'm not sure what are the rules of sharing this presentation with you, but if you want to have this presentation, just reach out to me afterwards. I'm happy to share it. Absolutely foster IP reuse-driven design. So every time that you are working with an asset that you think would be useful in other projects, work in a way that makes it easy for others to consume that asset. So this is IP reuse-driven design will save a lot of time, and you don't want to reinvent the wheel every time that you need to use an asset that you already have. Make sure your data is secure. SOS has a ton of capabilities to protect your data. Namely, you should make sure that each user will only have access to the resources that they need to access. And there's a ton that SOS has to offer in terms of access controls, in terms of encryption of your data, in terms of role-based access controls. Ensure governance and automation at scale. So SOS offers you ways for you to automatically call your own scripts, your own programs, and you can do it in reaction to an SOS command. So why trust, for example, that your users are doing their lint checks or their last mile validations? You can just simply tap into the triggers and do that automatically, and you will, first of all, take that effort off the users and also ensure that this is happening. This one might be a bit obvious, but you should maintain a clean and efficient project structure. What this means in terms of SOS is that you know that there are certain components of the project that your user doesn't need to work on. So the user typically only works on a small subset of your project data, even if they need everything that you have in the project work area. So what you can do with SOS is something like this, right? So you have the data that the user works on that is being fully populated into the work area. And then the rest of the components are modularized and referenced in the work area as lightweight references. I'm happy to go into more detail about this. Please meet me at the Keysight booth, and I'll explain how this is done. Also, there is a lot of data that exists in other projects that might be useful across different other projects. So SOS also has this concept of references that allows you to reuse data across different projects. Again, very obvious, but define your methodology ahead. So define what are the milestones that you're trying to achieve, what is going to be your tagging methodology, so that you don't end up in a situation where you have hundreds of tags, hundreds of parallel branches, you don't know which one to use, which one is the correct one. If you have toolset heterogeneity, namely in terms of data, let's say that you are working on an analog mixed signal project. You have part of your data in SOS, but you also have a digital team that prefers to work in Git. You don't have to force your digital engineers to move into SOS, okay? So SOS has a plugin layer that interfaces with third-party data managers. So you can have part of your data existing in external systems and still use SOS as the overarching cockpit. And again, leverage AI or at least be ready for it. So SOS offers a lot of capabilities in terms of you having your data correctly tagged and identified with labeling capabilities, with custom metadata structures, with lineage tracking. But then in terms of performance features, you also have capabilities that makes it so that any MLOps pipeline that you build out of SOS doesn't suffer latency that it doesn't need to suffer, so that you develop high-performance MLOps pipelines and reproducible AI. And again, just to wrap up, don't figure it out alone. So we're happy to help. Just reach out to us, and we will work together to identify your needs and what's the best approach. Just to wrap up this presentation, and thank you in advance for all your attention. If you have questions like for which your answer is no, like something like if you cannot survive if some server fails, or if you're not able to audit design changes that happened 6 weeks ago, or if you cannot share IP across projects without copy-pasting, if the answer to any of these questions is no, then your data is likely a liability, not an asset. So let's fix that, okay? You should visit the Keysight booth. I say this like 5 times already. You should visit the Keysight booth at the entrance. You can't miss it. Request a meeting with us. We're happy to talk to you. And why not? Connect with me. I'm happy to discuss this at some later point. And with that being said, thank you so much for your attention. And we have 3 minutes and 58 seconds for questions. Thank you. Awesome. That was super clear then.